You have any questions about like topics you wanted to review? Might be a short day. Hey, Kayla, we'll see. Hopefully we'll get some more people here as I fixed the link there and it should work now. We're just taking requests. So anybody have anything, any particular questions, topics you wanted to look at? Yeah, let me take a look at that practice exam. Let's see here. Hey, Sarah. Let's see. Now we're getting a couple more people. Hello, Daniel. Let's see. Is there a list of symbols, Brittany, or was it just the symbols that are in here? Or oh, wait, no, there's. I know what you're talking about. Yeah. There's another document. Exam 3 review. Yep. Cool. All right. So the name and explain the meaning of each statistic or parameter. So why don't I do this? Why don't I see if I can find the original and then I can type in as we go through here. Oh, sorry, I gotta try to get this file up. Let's see. So we're gonna start today with some review topics, whatever requests you have. There's an extra exam 3 review document and Brittany has asked us to, oh, I can't find it, to go over those symbols and answer kind of like what is each symbol's name, and then explain the meaning. So I'm going to, I think, download this file because I can't find the original. Okay, and let's see if I can open this in Word, and we'll take a look at these. Did you have any in particular, Brittany, that you wanted to look at? Or should we just go through all of them? Oh, my volume is like really loud. Wow. All right, here we go. We'll just go through all of them since I don't see any particular requests. So, oh, this is what happened. I remember some groups doing this when you try to import from a PDF document into Word. All right, so the first one here, this is the population mean. That's mu, the population mean. The meaning of it there, it's the mean of the entire population. S is the sample standard deviation. It's kind of self-explanatory. And then S squared is the sample variance. P is the population proportion, the proportion with whatever characteristic out of the entire population. It's not correcting it. Sigma is the population standard deviation, and then sigma squared would be the population variance. And you'll see that in the confidence interval questions that comes up. P hat is the sample proportion, the proportion of the sample with whatever characteristic it is that you're looking for. X bar is the sample mean, and then N is the sample size, the number of individuals in the sample. Okay, does that help, Brittany? Any additional questions about the symbols? All right. Any other questions? Feel free to just kind of shout out, or not shout out, but unmute yourself and speak up. Or if you have any specific questions, we're taking any questions about the exam, whether it's from the practice exam or from this review. Sorry, like my mic is scraping on my collar here. I don't know if I can fix it. Any particular questions about this week's exam, which will be over chapter 7, 8, and 9. This is where it'd be so good to just like let everybody get to work and then answer questions. Kayla, I think what I'm going to do, I mean, I will say, I'll be honest, like if nobody has any questions today, then it's like, well, today's kind of pointless. So I won't, maybe we'll just skip Wednesday and release it on Wednesday. My plan was to do review like we would usually do review. So my plan was to do review today and Wednesday and then release it on Thursday. Just kind of have it pop up Thursday morning. But, you know, if nobody has any questions, then I guess you're ready for the test and I can just have it pop up Wednesday. So it kind of depends on how today goes. I'm fine either way. It doesn't matter to me, but we shall see. So that's lots of questions, I guess, if you want. But either way, you'll have all day to work on it. I'll release it in the morning and then you'll have all day. And then just submit it to the Dropbox like you would in class. Same thing, just submit in Word format there. And then should be good to go. Any other questions? If it opens when, we'll have 1 day to work on it. Yeah, we'll have one day to work on it. That should be plenty of time. And if your schedule, you know, there's lots of flexibility here. You know, if you have your work and you're gonna have to work all day and you got another test there, you know, this is time to be flexible. Well, you gotta just contact me. You gotta let me know if you have an issue with those days. Just let me know ahead of time and we can just change the date for you. That's totally fine. But the plan is whatever day it is, we'll release it and you'll have that day to work on it. So any particular topics here? I've got like a list of things you could ask about. You could go over from the quizzes that we did. We did a couple of quizzes. We could do practice exam. We have this additional review. So in D2L, let's talk about what's in D2L. In D2L, under this week, we have 2 documents. There's an extra exam review, which is usually what I would do in class. The answers are there for that. And then there's a practice exam, which is an old exam. I think I actually added a couple things to it just to make sure it had all the examples, but it's basically an old exam. And then it has just some example questions. And your test is not going to be like the same thing with different numbers, but there's going to be a lot of overlap. And this just gives you an idea of how prepared you are. You're used to that. There's the practice exam. So we could go over any of those, but I don't want to waste your time and just talk about stuff if you don't have any questions. Yeah, Kayla, the T-stat versus Z-stat, it's a good question. Both are used when you are finding confidence intervals about the mean. So I have some, just a quick little topics I whipped up here, just kind of typing up what's in each section. So in confidence intervals, you have this confidence interval about a population mean. And in the homework in my stat lab, there was kind of both. There was a T-stat and a Z-stat, and sometimes like, how do I know which one to use? In the difference is, let me just, maybe I'll type below here. So the Z-stat is when the population standard deviation is known, and then a T-stat is when the population standard deviation is not known. The reality is that you rarely know the population standard deviation. So you're almost always going to use the T-stat. All the examples we did in class, all the examples, all the ones on the quizzes, those were all T statistics. There were a couple in the homework where you knew the population standard deviation, but that honestly is unusual. So when in doubt, if you're asked to find the confidence interval about a mean, you're going to use the T statistics. Yeah, so does that answer your question, Kayla? Mhm. All right, good. Good. So T-stat versus Z-stat. When in doubt, if you just always use the T-stat, then you'd be fine. You'd be fine. It's very rare that you know the population standard deviation when you're looking for a confidence interval for the mean. Like you don't know the mean, but you know the standard deviation. That's kind of weird. So that's very rare. All right, what else? What other questions? All right, Brittany has a question about the practice exam. Let's pull that up here. Number 3, given the two confidence intervals, which has a higher level of confidence? How do you know? The key here is, I wonder if I want to kind of like make some notes on this. Try to download it, and that's fine. Just give me a second here. Too many windows open. There we go. Try to put it over here in OneNote so I can like write on it. There we go. That looks good. So the key here is the relationship between width of an interval and level of confidence. So what you're doing here is you're trying to find a confidence interval for the average pulse rate for students at rest. So you're trying to find a confidence interval for the mean. This one here is 70, let's draw a little picture here, 70.9 over to 73.5. And then we have 70, which is a little bit lower, 70.0 up to 74.3. And the question is, which one has a higher level of confidence? So the level of confidence is how confident you are that the real mean is in there somewhere. So say we take a sample of 30 students, we find their average pulse rate, and we find a confidence interval for that using the techniques in Chapter 9. That's just a sample. We want to know, we really want to get some information about the average pulse rate of all students, but we just have a random sample. So that's what a confidence interval is. It says, well, we think the real mean is in here. So if you want to be more confident, well, the wider you are, the more confident you can be. And so that's the key here, that this interval is wider so you can be more confident. That is just terrible penmanship. More confident that it contains the actual mean. So it's all about width. That's the key there. It's all about width. Wider interval means you're more confident. Does that clarify that question, Brittany? Good. All right. Does anyone have any other questions? Either a topic you want to review? We have, where did they go? 3 chapters worth of stuff. Normal probability, sampling distributions from Chapter 8, and then confidence intervals from Chapter 9. It's just silence. Everyone's just waiting and hoping someone else has a question. I'm going to see if I can do a little poll here. Still waiting for questions. Any additional things you want to review? All right. We have Daniel asked a question. about number 11 in the review. All right, let me just finish up what I'm working on here. So let's open that up. I have lots of windows open here. Where did that review go? Number 11. I imported this into Word, so I have, okay, this one's easier than it looks. Let's see. So I would draw a picture. Whenever I have a normally distributed variable, I would draw a picture. So I think I can just draw in here. Yep, okay, that looks pretty good. So I'm going to draw a picture, and this is my variable x, which is normally distributed. Does anyone remember what number goes in the middle? Like, how do you know what goes in the middle on a normally distributed variable? Kayla's right, it's the mean. So in our case, that's our mu. This is why I'm glad Brittany did the review, asked about those symbols. That's why the symbols are so important. So there's mu, and we want to find the probability that x is less than mu. So that would be the probability of being to the left of mu. You didn't need a calculator for that. What's that probability? Justin is correct. 0.5, right? Just splits it in half. 0.5, 1/2. That is it. So the reason why I wanted to ask that question is I really think once you visualize it, that can help. So I would encourage you, whenever you have a normal distribution question, to draw a quick bell-shaped curve, just on your scratch paper or whatever, and kind of use that to help you get the answer. In this case, you're able to totally get the answer. Sometimes it just helps you. It's not enough. It doesn't totally do it, but in this case, that's all you needed. All right, we good on that one, Daniel? All right, excellent, excellent, excellent. Okay, what else? We got a couple of good questions so far. This is good. It's like a rainbow pen. Rainbow? Rainbow. Sorry. All right, what other questions do you have? Proportion problem. Do you want a probability proportion problem like from chapter 8, or a confidence interval problem from chapter 9? Or maybe both, but just let me know. Let me know. We can do either one. Confidence interval. Okay, so there's two things to keep in mind here. I'm just gonna write here because I have a white piece of paper. Two things for a confidence interval about a population proportion. This is like really hard to write like this. Okay. For a confidence interval about a proportion. In StatCrunch, you either have to do with data, which is actually, we haven't done that a lot, or with summary. We've done with summary most often. And with summary, what it's going to ask you for is the successes and then the sample size. So sometimes the successes are just given to you. Sometimes in class, we've done some examples in our practice where we were just given a sample proportion. So sometimes you need to calculate that. So the simplest would be I'm just thinking about Daniel and Justin and his project that he was going to do was about students in the AVID program. And let's say he does his survey, he ends up sampling, 83 students, and he finds that 67 of them would recommend the program, recommend, can spell. And so we want to create, let's say, a 95% confidence interval for the proportion of students who recommend the program. The first thing we should do is we should check to make sure we can do the interval. So we'll need a calculator for that. Does anybody remember what you need to check to determine if you can do the interval? Do you remember that? There was a thing to check if you're like, basically, if the sample proportions are normally distributed. There was a little check. I'm gonna get my calculator out here. Not seeing anything yet. Remember the n times p times 1 minus p? Yeah, something is greater than 10. It's not the sample size. It's the n times p times 1 minus p has to be at least 10. By the way, like when I'm turning my head, like it sounds loud to me, is it picking that up on the mic too? Or is it just me? A little bit, don't hear anything? Okay, good. Because some, like I have, I don't have any wireless earbuds, and I think that the mic is on the cable here on my son's Beats. I don't know, maybe I don't need the cable and I could just go Bluetooth. So I'll figure it out. So yeah, you need n times p times 1 minus p to at least 10. Now we don't have p here, we just have p hat. So we're going to do our best approximation for that. So it'd be 83 times 67 over 83 times 1 minus 67 over 83. And this is what you're doing only if it says, like, if it says calculate a confidence interval, go ahead and assume the conditions are met. But if it says, are the conditions met to do a confidence interval, this is what you need. You need to do this check. And this ends up being about 12.9, so we're good. So when you're given the sample size and you're given the number of successes, in StatCrunch, all you need to do is just, let's see, I'll just open StatCrunch and go stat, proportion stats, one sample with summary, and just type in, I think it was 67 out of 83, and then do confidence interval, 95%, hit compute, and there you're done. 72.2% to 89.2%. 70, was it 72.2 to 89.2? 72.2% to 89.2%. So that's the easiest. That's the easiest when you're actually given the number of successes. So you just type those in and the number total in your sample size, and then you just go from there. If you're not given that, let me see here. I don't think I can squeeze it in here. The other option is sometimes you're given, let's say you have a sample. I wonder, ooh, I have an idea here. I have an idea. I'm gonna open yet one more tab. This might be a bad idea, but it's an idea. I'm gonna open another tab and let's look for a poll. Let's look for approval poll and get a recent poll. They usually give you the sample size. So Rasmussen Reports did 1,500 likely voters, so that's your sample size, and they had 43% approve. So let's find a margin of error for that poll. So 1,500 is our likely voters, and they gave us a sample proportion of 43%. Okay, 1,500. And then the sample proportion is 43%. StatCrunch then, it's still gonna need the number of successes. You have the number of in your sample, but you're still gonna need the number of successes. So we don't know that, but we do know the number of observations is 1,500. It doesn't like me typing that. 1,500. Does anyone remember, and we did this, I feel like it was so long ago. I don't think we did it in class. I think we just did it like when we were on campus. I think it was after we left campus. Does anyone know how to find the number of successes if all you have is the sample size and the sample proportion? We did this in some of the college data. We did it a few times. Yeah, Rachel's right. She said you multiply, right? If it's 43%, well, it's 43% of the 1,500. So the number of successes will equal 0.43 times 1,500. And you can actually just type that in. You can just type it in here. .43 times 1,500, just like that. And then 95%, hit compute. And so your confidence interval for the Rasmussen report would be 40.5% to 45.5%. I'm kind of interested, if we clicked on that Rasmussen, like can we see? It's not going to show their margin of error. Total approved. Rasmussen poll, residential approval, margin of error. I want to see if it actually does that daily. Strongly approved, 43%. So they're saying plus or minus 2.5 percentage points. So that's their margin of error, 2.5 percentage points. Let's see what we got. We got 40.5 to 45.5 was what we got for our margin, for our interval. So 40, whoa. 40.5% to 45.5%. So how do we get the margin of error? We have our confidence interval, but how do we get the margin of error? I know we've talked about this before. Yeah, you can do, correct. Kayla said you can do upper minus lower divided by 2. So you could do, let's see, oh, that's just 5 divided by 2. 5% divided by 2 is 2.5%. Hey, look at that. That's exactly what the Rasmussen report did, right? Whoa, I have trying to tab through windows. I have too many windows open. But they had 2.5 percentage points as well. And that is exactly how they got their 2.5%, was doing it exactly like we did. So nothing, I mean, I was going to say nothing fancy. It's kind of fancy, right? This is not trivial stuff. But that's, so they're finding their margin of error the same way that we did. That 2.5 percentage points is because they sampled 1,500 likely voters. That's what that margin of error is from. Oh, and the 95% level of confidence. Cool. So let's see, this one, this was it Kayla's question? Yeah, Kayla's question. Those are pretty much pretty typical questions for confidence intervals. It's either you're given the number of successes and the n, and you just type those in, or you can be given a sample proportion, and then you can calculate the margin of error there, and then you're often asked, sorry, you can find the confidence interval, and then you're often asked for the margin of error, and you nailed it. You can take the upper minus the lower and divide by 2. That gives you the margin of error. Visually, for everybody else, what that means is you have 43% in the middle, and you're saying, well, it could be as high as 45.5% or as low as 40.5%. And so that half of that is the margin of error. You can do it that way too. Cool, good. Do you want to do another one? Is that enough? What are you thinking, Kayla? So you are wondering those are the ones where you're looking for the sample size. Does that sound right when it's saying how many should you sample? I think that's what you're asking about, I think. Let's see here. Yeah, I think so. Let's see if we can find one of those. I don't think it's going to be here. No, I don't think but I feel like there was one in the practice exam. Maybe not. We can find one. We can just make one up. I'm not seeing one. So let's just make one up. That's fine. Let's see. Let me go over here. I have the practice exam here. I'm just gonna see if I can go to the end and add another question at the end. All right. So let's say we are doing some polling, and we are the Rasmussen reports, and we have this margin of error. We did when we had 1,500 in our sample. It gave us a margin of error of 2.5%. But what if we wanted to do a 95% confidence interval, but we want to really narrow in that confidence interval and say we only want a margin of error of 1%. Let's say we want a margin of error of 1%. And so the question is, how many people do we need to sample then? Because we're going to need to sample a lot more to get our interval that much smaller. So there's a formula that you're going to want to write down. You'll have access to it. I should tell you what you can have written down, or maybe I'll put it on the test. That's not something you have to memorize. I used to have a formula sheet somewhere. But the formula for that, let's see if we can find that quickly. Oh, let's see here. We actually want to go to a different week. Just go to the online lesson is what I'm trying to find. I'm just going to click on chapter 7, even though that's not the right chapter. We'll go to chapter 9, population proportion, and then way at the end, there is a sample size necessary formula. There it is. P hat times 1 minus P hat times Z alpha over 2 over E squared. I don't know why you find that confusing. Okay, yikes. So P hat times 1 minus P hat times, oh, I lost it already, Z alpha over 2 over E squared. Okay, so that is our formula for the sample size necessary. The P hat, there's two options here. It can either be from some prior poll, a prior estimate, or if you don't know, you just use 1/2. 1/2 is, there's some algebra to it. You can prove that 1/2 is like a worst case scenario. I guess we kind of do have a prior estimate, don't we? We're kind of jumping around here, but what would be our prior estimate here if we're doing a poll about President Trump's approval rating and we're the Rasmussen company? Do you remember it? Right, we had that article. The most recent one was 43%. So we could use 43% for ours. Of course, on the test that would be given to you. And if you don't have, that would be given like, oh, if there was a prior poll, like it would be very explicit. It would tell you explicitly there was a prior poll and the estimate was 0.43, etc. And if you don't know, if you don't have a prior estimate, like I said, you just use 1/2. And so we plug some stuff in the formula. We have part of this, 0.43 times 1 minus 0.43. And then we have the E, 0.01. We got to square that. We do not have the Z alpha over 2. And the key here is this is a 95% confidence interval. So the alpha over 2 is 0.05 over 2, which is Z 0.025. And I remember we actually did find this one before, but we should talk about how to do it again. Does anyone remember how to find the Z 0.025? I will even give you a hint. I don't know if it's very helpful, but it's in the normal calculator. We're going to use the normal calculator. And so how do we find Z 0.025? Yeah, Kayla, you're right. You're right. The 0.025 is the probability. It's the answer. So she's saying you put the 0.025 over here. Now this, if I put compute right now, this is actually not correct, but we can figure it out from here. So the Z 0.025 is not actually negative 1.96. Interestingly enough, it wouldn't matter in the formula, but we'll get to that. So does anyone know why this is like almost there, that this is not actually Z 0.025? It's like, it's really close, but it isn't quite exactly correct. So if I wrote this down, negative 1.96, that would be so close, but not quite correct. I'd have to actually fix part of it. Do you know what it is? Brittany is saying it can't be negative. I'm worried about that can't be negative. You're right that it's positive, but the reason why it's positive is because the 0.025 needs to be area to the right, not area to the left. Now, in theory, I could do a Z subscript with something that's negative if it had more than half area to the right, but that's unlikely. So here is 0.025, and I just changed the inequality to be greater than, but you'll see all it is just a positive because the Z is symmetric. It's symmetric. It's 0 in the middle, and there's symmetry there. So you could really get it if you did less than and did just like Kayla said, and you say, well, but I know it's going to be positive, so I'll just put 1.96. So there's nothing wrong with that. That's totally fine. So it is just actually not, it's not negative. But it's not going to matter here either way because we're going to square it. So you could have done it wrong and put negative 1.96 and it would have been totally fine. Would have been totally fine. So now we just calculate 0.43 times 1 minus 0.43. I guess I could have done that one in my head. 1.96. Now this is going to be really big because we know it was already 1,500. Right, 1,500 to get a margin of error of 2.5%. Wow, check this out. 18,800, and we always round up, 832. So almost 20,000. So sometimes on these polls, they say, yeah, we'd like to be more confident, but surveying like 16,000 more people is really expensive. So we're going to just stick with our 1,500 and just go from there. So that's part of it. Is that would be a really big sample if you wanted that small of a margin of error. That's pretty difficult. So that was a good one to bring up, Kayla. All right, before we go for today, because I have to get ready for another class, I have a poll for you. This class started out really slow and then kind of sped up. So I have a poll for you on whether we should meet again on Wednesday or not. I will tell you that I will be much happier if you come with more questions because those were really good questions. once we got going. It was like really slow getting going. But it's a lot easier for me if you have questions. All right, good. We've got 5 out of 7, 6 out of 7 saying yes. That's fine. Everybody said yes who voted, and I cut it off. So that's good. Okay, good. I was like, maybe people are like, this is kind of a waste of my time. So that's good. It's always, this class is always so quiet. So for Wednesday, we'll keep working. Come with questions. I will have some additional examples, but it was really helpful when Brittany and Daniel and see a couple other people, Kayla had good questions. Like when you come with questions like that, that really helps, because then it's like, oh, then I'm not just like talking to myself, because nobody talks, and then doing stuff that I don't know if is helpful. So when you have something that you really want worked on, that's really cool. That really helps. Then we can kind of target it for things that you have questions on. What you should be doing for Wednesday is you should be in D2L. I can link these on the homepage. Why don't I do that when I post the replay, the recording from today? You should be under this week, and there are 2 documents for you to work on. I opened them today. One is the Exam 3 review, which is what I did last semester, last spring when I taught face-to-face. I did it in the classroom, but we can work on that together as well. And then the practiced exam. And there are already answers for those, but you can ask about those questions in class as well on Wednesday when we meet. And then Thursday, we will post the test. We'll post that on Thursday and have it due Thursday night. If you have a long work shift or something on Thursday and you're like, I'm going to be exhausted when I get home, and whatever, just you need to communicate with me. If you don't turn in your exam, then I kind of like, well, what's happening? But if you communicate with me, we can be flexible with that. But I need to know right away. I need you to, because I'm telling you right now, and I'm going to post what the exam dates are, so you can't email me like Thursday at midnight and, oh, I didn't have time. Like, that's kind of still suspicious. Okay. Any questions about what you should be doing or anything about the plan? Any questions before we log off for today? All right, I'm not seeing any questions. So I'm going to end this meeting, and then I will plan on, I was going to say seeing you, but I don't actually see you. I'll plan on logging on for our meeting again on Wednesday, same time, and we'll go over more of your questions. All right, study hard, everyone. Enjoy the rest of your Monday, and we'll talk again on Wednesday.